Hi folks. All right, today I'm going to be talking you through an example on interior angle misclosure for a traverse using an example that I have posted on Moodle. So I'm going to take you to the abbreviated version of the field notes for this particular group. They did a traverse around Kirby Hall of Civil Rights. And in this particular example, I want to take you through how they would take into account their internal angles and draw the angles they measured on their traverse drawing. So in this particular traverse, they started on the benchmark. They have TP1 where they set up, TP2, TP3, TP4, TP5, and TP6. So the place that usually you want to start from when you're thinking about interior angle misclosure is thinking about what should the sum of the interior angles be? What should that number be? And so in this particular case, we want to focus on the traverse. Our traverse around that building is the lines that I am connecting right here. It extends from TP2 to TP3, 4, 5, 6, and back to TP2. We have how many internal angles? We've got 1, we've got 2, we've got 3, we've got 4, and we've got 5. N equals 5 in this case. So the sum of the interior angles we often define as n minus 2 times 180. If you ever can't remember that, just think of a triangle, right? Triangle has 3 interior angles, 3 sides. 3 minus 2 is 1. 1 times 180 is the sum of angles in a triangle. So in this particular case, we've got 5 minus 2 times 180, and that is equal to 540 degrees. So eventually, when they add up the angles from TP2, 3, 4, 5, and 6, that number should be close to 540. The difference between the sum of those angles and 540 is their interior angle misclosure. But I also want to talk you through what their measurements actually look like on this traverse and how you would draw that. So we're going to start here with the setup on TP1. They backsighted the benchmark, and it says their horizontal angle, which is always what we look for when we're doing internal interior angles. It says their horizontal angle there is 0. That means that that line that I'm shading in red right now is their 0 line. Total stations always measure angles clockwise. So in this particular case, the angle that they measured started on that line, wound around until it hit TP2. TP1, they foresighted TP2 and they measured that horizontal angle to be 252-43-24. Then they moved their instrument. They set up on TP2. They backsighted TP1 and they foresighted TP3. And they measured that angle to be right here, 199-46-22. They moved to TP3. They set up on TP2, or excuse me, they set up on TP3. They backsighted TP2. They foresighted TP4. And that angle they measured as 115-27-12. Set up on TP4. Did the same sort of thing. They got 108-553, which is right here. And they finally set up on TP5. Backsighted TP4, foresighted TP6, measured an angle right here of 87-35-38. And then last but not least, set up on TP6. Backsighted TP5, foresighted TP2. Again, that angle is being measured clockwise. And we have 108, 16, and 32. So in this particular case, they have a number of internal angles, interior angles to their traverse, but they were missing this last angle here. And so usually I use this example to talk about how important it is to set up on TP2 again and get that last measurement. They wouldn't be able to calculate their interior angles. They would need to go out and take one more measurement. But once they have that measurement, they can add up all those interior angles together and compare them to 540 to calculate their interior angle misclosure.